All right, y'all, let's look at some molar conversions. With molar conversions, you're simply just converting singular elements. We're not doing compounds and reactions and all that stuff yet, but we're going to be converting between and among grams, moles, and atoms. Anytime you need grams, you're going to use this number from the periodic table. It's just the average atomic mass from underneath each one. It's that decimal number that you see on the periodic table. So anytime you have grams, you're going to need the number of grams for that element. And then anytime you see atoms, we're going to use Avogadro's number. And my students use 6.022 times 10 to the 23rd atoms for that one. Okay, I just showed you the examples for carbon here. It's not always going to be this number for grams. It's whatever that number is from the periodic table. The other thing to keep in mind is that when you are converting from grams to atoms or atoms to grams, you have to go to moles in between. This will help you later on in the year when we're doing stoichiometry. The first question that we have here is 7.349 times 10 to the 24th atoms of carbon is equal to how many moles of carbon? Okay, so we're starting with atoms and we're trying to get to moles. There's an arrow that connects atoms to moles, so I know that it's just a one-step conversion. Okay, usually I have my kids say, okay, given, write this out. Atoms, carbon. Remember, anytime you write a number, you want a number, a unit, and the chemical that goes with it. So G is given, U is unknown. What am I trying to get to? Okay, I don't have a number for that because that's what I'm trying to find. But it says how many moles of carbon. So I'm looking for moles of carbon. That's my unit and chemical. The first thing that you do when you're doing these problems is you always start with your given. So I'm going to write my given here, 7.349 times 10 to the 24th atoms, carbon. Okay, and then we're going to do our next fraction. If it makes you feel better to write a 1 under here, you can absolutely do that. It's not going to change your answer mathematically, but I know some people like to just have something in every single spot, and that's completely fine. Once you have your given here, your unit and chemical go to the bottom of the next one every single time. Okay, the reason for that is you are trying to cancel these units out. So anything that you have written at the top, okay, not the number, but the unit and chemical, that's always going to go down here for the next one. The unit and chemical up here, okay, it's going to be the same chemical, but this unit depends on what you're trying to get to. I'm just trying to go to moles here, so I'm going to put moles. I can go from atoms of carbon to moles of carbon because I know that for every 1 mole, there's 6.022 times 10 to the 23rd atoms. Okay, for any element, it's always like that. This is what I was showing you before. 1 mole is equivalent to 6.022 times 10 to the 23rd atoms. That's for every single element. The only number that changes is the grams for your different chemicals or elements. Okay, because I have this in moles of carbon and I was trying to find moles of carbon, I know I'm done at this point. The only thing I have to do is put this in the calculator. The thing that you need to be careful with this one is if you have a scientific notation number on the bottom, you must put that in parentheses. Unless you set it up as a fraction and you do it like that. Most people don't do that. So we're going to start with our given. I'm going to show you exactly how to do this. Start with your given. 7.349 times 10 to the 24th. Okay, make sure you hit over so that you can get out of that exponent. Then anytime you have a number on the top, you're going to multiply. Anytime you have a number on the bottom, you divide. You can do times 1. There is a 1 on the top, so you would multiply by 1. That's not going to change my answer. Multiplying by 1 doesn't do anything numerically, so I'm going to skip that. If you have a number on the bottom, you divide. So this I need to divide by. However, if you don't put this in parentheses, it's going to divide by only this part, and then it's going to multiply by 10 to the 23rd as if that was on the top. And we don't want that to happen. So parentheses, 6.022 times 10 to the 23rd. This is your answer. Now, sig figs. Okay, how many do I need? Well, I'm dividing, and both of them have 1, 2, 3, 4, 1, 2, 3, 4. So my answer needs to have 4. 1, 2, 3, 4. So 12.20. That's your number. That's your unit. That's your chemical. Okay, on to the back page. How many moles are in 28.00 grams of nitrogen? Sorry, I'm having a little bit of paper issue here. How many moles are in 28.00 grams of nitrogen? So that's my given. Whatever number is given to you, that's your given. Your unknown is what you're trying to find. This is how many moles. So question mark moles. Oh my goodness. Nitrogen. Okay, start with your given. 28.00 grams nitrogen. Whatever unit and chemical you have on the top always goes on the bottom of the next one. Okay, unless you're done and then you're writing an equal sign here and you're not trying to figure out what goes on the bottom. If that's not the case, your unit and chemical always go on the bottom of the next one, every single time. Okay, for this one, I'm just going from grams to moles. My given was grams, my unknown was moles. Okay, and you can go from grams to moles. So grams, moles. It's still nitrogen. I'm not using any other kind of element. Okay, and then this is the other equivalent statement that we needed to use. 1 mole equals the average atomic mass for grams. Okay, nitrogen is 14.007. So that's the number that's going to go here, 14.007. I was trying to find moles of nitrogen. I have moles of nitrogen on the top, so I know I can write my equal sign. I'm done. Put it in the calculator. Start with your given, 28.00. Okay, like I said, you can multiply by 1 or you can just skip that part. Same thing with if the 1 is on the bottom. Doesn't matter. Divide by 14.007. That's on the bottom, so we divide by that. Okay, how many sig figs? 1, 2, 3, 4. So 4. 1.999. Remember, grams cancels. Moles of nitrogen. That's what's left. Okay, if you did all of this correctly, you don't have to check that everything crosses out. Your answer is going to be whatever unit this is. You're just going to move that here. All right, number 3, how many atoms of helium are in 5.96 grams of helium? So given 5.96 grams of helium, what's the unknown? What am I trying to find? The number is always a question mark. This is how many atoms of helium. Okay, start with your given. Always start with your given. 5.96 grams of helium. Okay, what should you be doing already? What do you know comes next? Grams of helium was at the top, so it has to go on the bottom of the next one. Okay, now if you flip back to this other page, we had grams to moles, moles to atoms. You can't go from grams to atoms, so we need to practice that. You have to go from grams to moles to atoms. So I shouldn't just be writing atoms here. I have to go from grams to moles, which means I'm not done, so I'm going to have to do another fraction. You can put these numbers in first, or you can fill out these units and chemicals. It does not matter what order you do this in. Whatever is easiest for you is what you should do. Moles of helium was at the top of this fraction, so it goes on the bottom of the next one. Okay, just like when you're bringing the given down. Whatever is at the top of the last one, if you're not done solving this problem, it goes on the bottom of the next one. Okay, now I'm at moles. I went from grams to moles. Now I'm going from moles to atoms. Okay, now I'm done because I'm trying to figure out how many atoms. So once I have atoms at the top, I'm done. Now let's go back and put the numbers in. Moles and grams. That equivalent statement is 1 mole is equal to the number of grams of that element. Okay, I need my periodic table. Helium's right here. This is my average atomic mass, 4.003. So that's how many grams go here, 4.003. The next one I have moles and atoms. Okay, the equivalent statement for that is 1 mole equals, okay, how many atoms? Avogadro's number, 6.022 times 10 to the 23rd atoms. Okay, now I can put this entire thing in the calculator. Start with your given, divide if the number is on the bottom, multiply if the number is on the top. For this, it does not matter if you put this in parentheses. If you want to, so that you don't have to remember when you are or not supposed to or don't have to put that in parentheses, just always do it. And then you don't have to worry about it. Okay, but it's not necessary when it's on the top. So for this one, 5.96 divided by 4.003 times Avogadro's number. Okay, this is my answer. How many sig figs do I need? 1, 2, 3. So I'm doing 1, 2, 3. This is a 6. This is what I would keep, but it's 5 or higher after it, so I round this up, so it would be 8.97. Also, don't forget to look over here. Don't just put 8.97. It's 8.97 times 10 to the 23rd. Okay, the times 10 to the 23rd does not count in your sig figs. However, you need to make sure that you keep this order of magnitude. Okay, if someone was going to give you $8.97 or someone was going to give you 8.97 times 10 to the 23rd dollars, there's a big difference. So make sure that you are looking at the end of that. Don't forget it. That's your number. This is your unit. This is your chemical. Okay, atoms of helium. Last question for this. What mass of sodium is equal to 1.19 times 10 to the 20th atoms of sodium? Okay, what's my given? It's the only number that I am given. So 1.19 times 10 to the 20th atoms sodium. Sodium is Na. Unknown. Well, what am I trying to find out? What mass? So question mark, unit. Do I just write mass here? Mass is not a unit. What is mass measured in? Grams. That's the unit I should be putting there. Okay, so this is like the above one, but instead of going grams to moles to atoms, I'm doing that backwards. Atoms to moles to grams. Okay, so you can write that here if you want. Atoms, moles, grams. Start with your given. 1.19 times 10 to the 20th atoms sodium. Always, always, always start with your given. Okay, what do you do next? Put your unit and chemical on the bottom of the next one. Whatever's on the top of the previous one goes on the bottom of the next one. Atoms of sodium. Okay, after atoms, it says I'm going to moles. So we're going to have moles of sodium. That's not what I'm trying to find, so I got to keep going. Whatever was on the top of the previous one goes on the bottom of the next one, so we can cancel. Now that I'm at moles, I can go to grams. And now I just have to go back and fill in the numbers. Okay, moles and atoms, that equivalent statement is 1 mole equals Avogadro's number for atoms, 6.022 times 10 to the 23rd. grams of sodium and moles of sodium. 1 mole of sodium is equal to 22.990 grams of sodium. 22.990 grams of sodium. Okay, then you just got to plug it in. Start with your given. Divide if it's on the bottom. Multiply if it's on the top. This number, what do you need to make sure that you do? Put it in parentheses. Otherwise, it's going to only divide by this part, and it's going to multiply by this as if it was on the top. Okay, here we go. In the calculator, 1.19 times 10 to the 20th divided by, ooh, see what I did? I forgot to go over. Let me delete that. Now over, divided by, parentheses, Avogadro's number, over, I remember this time, and then multiply by 22.990 because that's on the top. Ooh, that's a small number. All right, sig figs, we started with 3. So I need to end with 3. Remember, this 0.00, none of those are significant. You have a decimal, so you're starting from this side. Go past all the zeros. The first significant digit here is this 4. So I would keep the 4, 5, and 4, and there's a 3 after that, so it's telling me leave that 4 alone. So 0.00454. Unit chemical. Number unit chemical every single time.